so there are two parts in this setup, and we have battery here, so we could label it that's positive and that's negative. Okay, so that would be maybe a right positive and negative. That's the first part you can do after reading the diagram. And then let's consider what's going to be attracted to these electrodes. So, okay, on the left-hand side, at the positive electrode, so that means negative ion, anions will be attracted here. So we can find out what's the anion in the solution. Oops, too big. Okay, so we got chloride ion. It's very dilute chloride ion, which will be attracted to here. And also remember, water will dissociate to provide hydroxide ion. So these two ions will be attracted to electrode A. Okay, and we know on the electrochemical series, hydroxide would be preferentially discharged because it's a stronger reducing agent. Okay, so for this one, it should be hydroxide which turn into oxygen. The oxygen produced at A. Okay, for part B, because this part is a special case involving mercury, so not included in this unit. So let's leave part B. Okay, and then for C. For this part, we also got sodium chloride as the electrolyte. However, on this side, we got iron as the electrode, so not inner electrode anymore. Okay, we got a metal as the electrode, so you need to consider whether the metal gonna involve in the reaction or not. So again, we should be able to write what is the ion that attracted to this side. So for the positive one, okay, negative ion will be attracted, and for the negative electrode D is the positive ion. Okay, so for these two, sodium ion and hydrogen ion, we know hydrogen ion will preferentially discharge to form, okay, hydrogen gas. Okay, and then for electrode C, it should be the metal that involved in the reaction, okay, and then become Fe2+. Or we can check on the electrochemical series. Oops. Sorry, what do you have? Just move it here. All right, so wait a second. Oops. So now we got chloride ion, hydroxide ion, also Fe. Okay, so if we check on the electrochemical series, we got use a different color. Okay, so ion is here, and we got hydroxide ion here and chloride here. Okay, so as we go up, it gets the reducibility increase. So among these three, we know that ion going to be the one that losing electron. Okay, so these three. So here it would be ion that change into ion 2. Right, so if we then with all this information, you should be able to pick up the correct answer. Okay, so any question for this one, for the first MC? All right, so then Emily, are you with me? All right, so move on to the next one, question 2. Which of the following method can slow down the corrosion of an iron-made object? Okay, so it's related to Unit 13 you learned last year. So the first one, connected to a piece of lead. You need to remember the reactivity of metal. So iron is actually a more reactive metal than lead. So the reactivity iron is more reactive than lead. Right? That means if we put a piece of lead onto the iron, then iron would lose electron more readily to lead, right? So not, and then speed up the process. So definitely not one. Right? And then, so it was left with B and D. And then if we take a look at the third one, connected to the cathode of the chemical cell. So I don't know if you still remember, we learned a method called anodization. Okay. We're approaching the 40 minutes limit, so I might set up another one, okay, later. But in Unit 14, we mentioned this process, so anodizing a aluminium in order to thicken the layer, so it prevents it from corrosion. Okay, so it should be connected to the anode, not the cathodes. Okay, so that's for this one. Okay, so yes, for this part, please check the your Unit 13 notes from last year. It's not a chemical cell. And it should be the electrolytic cell. You're not doing chemical cell. Okay, so next one. All right, so this one is a bit trickier. So I've got lots of notes to help you to understand this part. So again, you got two half here, right? Two half cells. And for each one, again, we use the same method. We have to label all the all the mobile ions in the electrolyte. And also if we got hydrogen gas that's bubbling into the solution, we also need to take into consideration of that. Okay, but if we take a look at the electron flow, okay, so here electron flows into the external circuit. So that means it loses electrons. So at these electrodes, it should undergo oxidation, and that's the anodes, right? It provides electron, okay? And then on this side, the chemical is going to gain electron, so it will undergo reduction. So that's the cathode. Okay? And then let's list out all the ions in part A and part B. So part A, we got 1 molar of HCl, so it's dilute hydrochloric acid. And what's the ion exist in the electrolyte should be hydrogen ion and chloride ion, okay, dilute concentration. And also we got hydroxide from the dissociation of water. And also we got hydrogen keeps bubbling into the electrolyte, so we can write that. Okay, so at this part, we need to consider which one is actually going to gain the electron. Okay, so for sure we know chloride and hydroxide will not prefer to gain electron. Right, so we can cross that out. And then we need to consider, is that the H plus or hydrogen that's going to gain electron? So if hydrogen gains electrons, the only possibility is for it to become hydride ion, which is very reactive and very unstable. Okay, so it's not likely, so you would not consider it. So at part A, it should be okay. The hydrogen ion that's get discharged. So at this electrode, it would be hydrogen ion gains electron and become hydrogen gas. Okay. So we use the same method to analyze component B. Again, let's write out all the ions in the electrolyte. So 1 molar sodium hydroxide. So would provide sodium ion, hydroxide ion. And then hydrogen ion from dissociation of water, and again it keeps bubbling hydrogen gas into it. So we got all 4 substances near the electrode. Okay, and then let's take a look which one is actually going to lose electron. So definitely not easy for sodium ion or hydrogen ion to do it. Okay, it's very hard for you to take away electrons from a positive ion. Okay, and then let's take a look whether hydroxide or hydrogen would be preferentially discharged. Okay, so for this one, we can check our electrochemical series. Right, so we got hydroxide at this part, and we got hydrogen at this part. So you can see hydrogen at a higher position, so it would be preferentially, it would prefer to lose the electron. Okay, hydrogen. So it will actually be hydrogen that become hydrogen ion. Okay, so the equation would be like this. Okay, and then one thing you need to note is that in this part, we have 1 molar of sodium hydroxide. It's an alkaline solution. So alkaline solution, it should have no H plus left in the solution, isn't it? Okay? So in alkaline solution, you should not be able to find H plus. So how to balance this, or how to remove the H plus? It's gonna react with the OH minus in the solution, so we can add OH minus onto both sides. Yeah, so if we add 2 hydroxide on the left hand side, 2 hydroxide on the right hand side, and then we can turn the equation into 2 OH plus hydrogen, and then become 2 water and 2 electron. Okay. Right, then we finished analyzing these 2 parts. So you can check the answer, check those statements, whether it's correct or not. Okay, so because here we got 1 molar of sodium hydroxide in the solution. Okay, so no matter, whenever we have H plus formed, okay, so it will combine with OH minus. Remember the dissociation of water? As a reversible reaction, so it can go this way to form H plus and OH minus. It can also go backwards to form water. And actually, it would only a small amount of H plus and OH minus would be formed, and also here we got sodium hydroxide in the electrolyte. Okay, so there are loads of OH minus. Hence, it will try to push the reaction go to this side. So the H plus form would combine with OH minus. Okay, so that's my hint. Okay, so you can when you get the equation, you will be able to work out the pH change, whether hydrogen ion is removed or hydroxide ion is removed, and also you will be able to deduce is it a reducing agent or oxidizing agent. And also, if you add two half equation, it will give you the overall equation. So I will stop here and let you to check all the statements on your own. Okay, next one. The porous pole again let the ions move to balance the excess charge. It's the porous pole here is mainly for separating the two solutions, because on the left hand side we got HCl, on the right hand side we got sodium hydroxide. So we need a porous pole. Okay, next one. Okay, for this one, okay, again the diagram. So when we see the battery, we will be able to label the positive and negative electron. So negative electron sends electron, okay, negative gains electron, positive lose electron, and then it gains electron, it loses electron here. Okay. So it says, which of the iron rods would a metal be plated? So if we want to place a metal onto the rod, you should expect a reaction like this. Okay, the metal ion in the solution should gain electron and turn into metal, the metal which is going to be plated onto the rod. Okay, so since it's gaining of electron, so there are only two possibilities. It only can happen on rod 2 or rod 4. And then at these two electrons, we need to consider which one is the correct answer. So back to our step 1, we need to list out all the ions that are going to be attracted to here. So this part is the negative electron, so the cation is going to be attracted. So this part, cation would be copper 2 ion. Okay, in the solution we got copper sulfate, copper 2 sulfate, so copper 2 ion, and also hydrogen ion from dissociation of water. And then similarly, we do it for rod 4. In this cell, in this part, we got magnesium ion and also hydrogen ion. And then we need to compare the reactivity. Okay, we can just simply check a electrochemical series, or we can deduce it by comparing the reactivity. If we compare the reactivity, you know copper cannot react with acid. Okay, that means copper is less reactive than hydrogen gas, but magnesium can react with acid to produce hydrogen gas. So actually magnesium is more reactive than hydrogen gas. Okay, so remember, if it's pretty stable as a metal, then its ion will be pretty unstable and will be readily gain electron to go back to the metal. Okay, so copper 2 ion actually among all three is pretty reactive. Okay, so it it should be the copper 2 ion that get preferentially discharged. Okay, so copper 2 ion will undergo this reaction that gain electron and turn into metal and coated on the rods. Okay. So any question for this one? Can we move on? Hi. Yes. Okay, so for this one I think is pretty straightforward because we have discussed it in the case 2. Okay, case 2, sodium chloride. The only difference is that we add a litmus indicator here. So you need to remember for litmus indicator, it will show red in acid and show blue in alkali. Okay, so for this one, as the positive electron, it will be hydroxide ion that got discharged to form oxygen. As the negative electron, it will be hydrogen ion got discharged to form hydrogen. So on the left-hand side, because we are using, for example, on the left-hand side, the negative electron, since we are using H+, right? So there should be excess of hydroxide ion near the negative electron. Okay, hence the pH will change accordingly. Okay, so if we got more hydroxide ion, OH minus, the solution around this negative electron would become alkaline. Okay, so the color will change accordingly. Okay, any question for this? Okay, so easy one. Let's move on. Next one. Okay, so here the diagram shows a setup for electroplating of a spoon. Okay, which of the statement gonna be correct? So for this one, it plays a metal, and the metal should be placed as the anode. Remember, that's a setup for yes, alkaline should be more OH minus. Is it wrong? Okay. If it's an alkaline solution, you're gonna get more hydroxide ion. If it's acidic solution, you're gonna get more hydrogen ions in it. Alright, sorry, I jumped back. Let's move back to here. So remember, the object we want to be plated should always be placed at the cathodes. Okay, and the other one, it should be an electrode connected to the anode. And then the aqueous solution that contains silver compound, okay, it should be a soluble compound of silver, so it would be able to dissolve in here and also conduct electricity. Okay. And if we take a look at the choices provided here, A, M must be silver. It sounds reasonable, but whenever you see a statement got mass in there, you would need to pay attention. Okay. Let's read part A first, and then part B. Q can be silver chloride. Remember, silver chloride, lead chloride, they're all insoluble salt. So part B should be wrong answer, wrong statement. And then it would not form aqueous solution. So part B should be wrong. And then the next one, the spool is connected to the negative pole of the battery. Yes, negative pole and the cathodes. Because what we want here is silver to gain the electron to become silver, and the silver then plates it onto the spoon. So it should be connected to the negative pole. Electron flow from metal M to the spoon through the solution. Okay, so here that we know silver will gain the electron. So yes, electron then it comes in at this part. So it will be lost at the other side of the electron. So yes, it will flow from M to the spoon, but not through the solution, but through the external circuit. Okay, so now we're left with A, okay? Should M be silver or not? Yes, it's from negative to positive, yeah. But electrons are not floating here. It's the because it's gained by the ions in the solution. It's not electrons freely move in the solution here. It's gained by the ion and it's lost by the ions, and then the electron flow through the wire. So take a look at this electrode. Right? We want something to lose electron. However, it doesn't have to be silver. Okay. Silver is an ideal case because as in our notes, we said at this part we want the silver rod. That's because if we place silver rod here, silver will become silver ion and lose electron. So this silver ion actually replace the loss of silver ion in the solution. So this reaction can last longer. Okay. However, it doesn't have to be silver that lose electron, right? It can also, remember, there are two types of materials that we can use for electrode we learned in this unit. It can also be inner electrode. Okay, so in here we can also use inner electrode, like carbon or platinum. Okay, so if we use inner electrode here, it will be the hydroxide ion attracted to this positive electrode and then turn into oxygen gas. So it doesn't have to be silver, although silver will be an ideal case. But if we place an inner electrode, it will also help us to play a thin layer of silver onto the spoon. Any question? Yeah, that's why I repeat it again. So it doesn't have to be silver. And I gave you an example. Okay, what's an alternative choice? Because using silver is not the only choice here. We can also use inner electrode, and it will also provide electrons to the external circuit and complete the circuit. Right, so here, because it sends out electrons, so that would be the negative side. That's a positive side. Just one more question, and then easy one. Okay, quickly, last one. So again, is the anodizing of aluminum object. You can refer back to your Unit 13. Unit 13 notes. So again, for anodized and aluminum object, the reaction for this reaction, the purpose is to thicken the aluminum oxide layer. Okay, so we want to turn aluminium into aluminium ion. That's the purpose of doing anodization. Okay, so aluminium turn into aluminium ion, it will lose electron, so it undergo oxidation. Okay, so it will be the anode. Okay, so it lose electron. It will be the anode. Also, it connects to the positive side. So we can only choose from B or D, the aluminium object. Okay, and then the next question is, okay, which solution we need to choose? If we take a look at option 4, the electrolyte we use here is concentrated sodium chloride. So at the positive electrode, it will have a lot of concentrated chloride ion and also some hydroxide ion. Okay, so as we mentioned, if we have a lot of chloride ion near that electron, and then those chloride ion would preferentially discharge. Okay, so it will be the chloride ion got discharged to form chlorine. Okay, and here we also got aluminium. Yeah. Right, so because loads of chloride ion around that electrode, so it would preferentially discharge from chlorine. So not aluminium, which lose electron to form aluminium ion. So the correct answer should be B. Any question? B. B for boy. Okay, so I will